All right, so here's the screencast for objective number 2 of the chemical reactions unit. So decipher how to write a word equation. What's the basic setup? What's the symbolism? So our essential question is, what is the basic setup for a chemical equation? Some of this you've already seen, so this would hopefully not be too much new to you. So deciphering word equations. The basic equation format, we tend to write it in a blank and blank yields blank and blank format, meaning I take this and I combine it together, and then the arrow means yields, so I produce this and this, kind of our general format. And can also be reacts with or plus or added to or another conjunction. It just means the plus sign. So if I have this reacts with this to produce this and this, there's just some terminology that goes with it. Yields can also be to form, produce it, really draw it as an arrow. A lot of times you see this as the reactant plus the reactant yields the product plus the product. There might only be one reactant or one product, but this is just a general setup for you. Some signal words to be aware of. There might be the state of matter. Don't forget to watch out for those diatomic elements: hydrogen, nitrogen, fluorine, oxygen, chlorine, bromine, and iodine. They exist as pairs when they are by themselves. You don't write H, you would write H2. If you see an S after something, that means it's a solid. Usually those are ionic compounds that are not going to be soluble, meaning they are insoluble in water. Except for acids, we will put acids as aqueous because they will break apart. So like hydrosulfuric acid or sulfuric acid, all of those you'll see AQ at the end of them. Liquid is L. Gas is going to be signaled with a little g. A lot of gases are molecular compounds. There are some solid and liquid molecular compounds. Solution means dissolved in water. So we see something is aqueous, meaning it has dissociated, it has broken apart, it is now dissolved in water. If you see something that has an S behind it, that generally tells you that it is not soluble in water. So it's going to stay a solid no matter where it is. This would mean that it would dissolve in water. So the basic, or the easiest way to learn how to do this is just to practice. And the next 2 slides, or the next 3 slides, have you do just that. You should already know how to write these formulas. That's what we did in the nomenclature unit. This is why we did the nomenclature unit, was so you knew how to write the formula for lead 2 nitrate. So you're going to need your periodic table, you're going to need your polyatomic ion chart, and just write these formulas out. This means the element zinc and lead 2 nitrate, so this and this, would react to form zinc nitrate and lead. And all you have to do is write the formulas down and put it in the correct symbolism. Put the pluses where it should be, put the arrow where it should be. We will do these in class. I will go through and I will work these in class with you just to make sure everybody knows how to do this. But I challenge you to just do this. See if you can do it. If it tells you the state, like on the next one, it says aluminum bromide plus chlorine gas, write the state in there. And if you feel that you want to take it to the next level, you can go ahead and practice balancing, because that's our next objective. So there's 3 here, there's 3 on the next slide, and then there's 2 more here. So I challenge you to try these. See if you can complete these 3 slides, and we will go over this in class and see where everybody's at. So the summary for objective number 2 is a 20-word format, and that's all you have to do for objective number 2.